Okay, it's Tuesday, it's 1 o'clock. Welcome to another HDF clinic. And I checked the meeting earlier. I checked our question sort of assembly point earlier, and there was a question. Great. Thank you very much to, I believe, Sean Freeman, who left that question. And the question that he asked is if there was any experience using HDF5 for MPI parallel HDF5, I take it, output with compression. So I imagine when he does H5 write, H5D write, he writes to a data set with chunking and compression enabled. But his underlying Eluster file system is configured with progressive striping. So if I understand that correctly, it's just set up in a way that you can set up striping on a file, for example, that you, to different regions in the file, you can assign progressively more OSTs, object storage targets, so you can have fewer in the beginning, because you might think, okay, I'm going to write metadata and so forth at the beginning, so I don't need that many OSTs there. But then as the offsets in the file sort of grow, you put in more and more OSTs. And he's saying they are seeing file corruption and wondering where the problem lies. Personally, I don't have any idea, because I think the implementation of HDF5IO in parallel to chunk data sets does not use any file system specific features. So it's really portable, if you want to call it that sense. So that implementation is the same whether you use GPFS or OrangeFS or Luster. But I checked with Jordan Henderson, my colleague Jordan Henderson, who is sort of the main guy behind the parallel chunking with compression implementation. And his response, which I have repeated here, he said that really nothing comes back to his mind, but his question would be, and unfortunately, if Sean is here, please speak up, but he would be Jordan would be interested in learning which MPI version and which MPIO backend you are using. And because there were some issues in the past with Romeo, for example. So Sean, if you are here, can you say something to that? Or
yeah, sorry, I joined a little late.
Oh, that's okay.
So yeah, we're using the HPE MPT, which comes from the SGI MPT, and I don't remember where the heritage of that is, but I don't think it's using Romeo for MPI-IO. And I'll note that we can't reproduce. Okay, we can reproduce the issue, but it's only in certain times for certain files. Most of the files turn out fine, just that some of them come out corrupted. And we've had variables corrupted, and we've actually had the variable list corrupted before. So some of the metadata gets corrupted. And it's only once we fix the stripe count, it's fine. But if it's on the progressive file striping, it just doesn't seem to.
So do you think you could produce a small, like a minimum reproducer, or and if you can share that with us or Jordan? I mean, all I would do is forward it to Jordan to try. But if you could, provide a small test program that maybe not all the time, but sometimes produces that behavior, then we could try that.
Yeah, I have a minimal reproducible example of the way that we do our HDF5 writing. I haven't tried to reproduce this specific error with that little test program, but I gotta say, I don't know that I will be able to reproduce it with that, because it's been in our main program, we've had it, but it's been sporadic. Not so, it's common enough that it's an issue, but it's still pretty rare. So I can get in contact with Jordan if you'd like, if you can send me his email, then
I will. Yeah.
Thank you.
Yeah. Okay. Send Jordan's address. I think his email address off the top of my head is probably just J Henderson. So JHENJ at hdfgroup.org, but I'll confirm that.
Yeah, that's right.
Okay, yeah, so it's J Henderson at hdfgroup.org, and yeah, Jordan's. Yeah, so sorry, it's really, it's definitely, as far as the implementation goes, there is nothing in the implementation that is specific to Lustre or GPFS or any of the other parallel file systems. But it could be sort of a subtle, when you use a certain feature. And since you say there is metadata involved, it could be related to, since I'll come back to that later, related to atomicity, maybe because MPI atomicity, that is. And yeah, who knows? There could be sort of a subtle interplay going on, and ultimately a bug or something. Maybe you need another barrier somewhere or enable MPI atomicity or something like that. And, but it's hard to say. Yeah. Sorry.
No, you're fine. I just wanted to, I mean, we've got a workaround. We can just fix the striping count. But I thought I would ask and see if this is a known issue or not. But I'll email Jordan with some more details then. Thank you very much. Okay, thank you. Yeah. Thanks for asking the question. So yeah, are there any other who was able to join you today? Welcome. Are there any other questions that you want to ask right now? I mean, I will pause several more times, but now is as good a time as any time to ask a question if you have one. No? Okay. I keep carrying this forward. I still owe you an answer to the question whether the file locking changes from 112.1 will come to 110.8. Probably 110.8 will be released, and then I will just look in the release notes. But no, I hope I can get you an answer before that. Okay, last week's highlights. Let's have a quick look here. Oh, number one is still, you have time, we all have time until August 1st to throw in our hat for the HUG event for the Americas that's coming up in October, but the deadline to submit an abstract for presentation or a paper and presentation is August 1st. And again, if you want to know more about the format or you are unsure, is this the right material, check out our YouTube channel. We just had that event in Europe, and the videos and presentations are online, and it's fantastic material. And so if you're looking for inspiration, definitely check that out. A second thing is I can show you, I have a browser window here as part of sort of putting more and more of our documentation with the source code in Doxygen and so forth. I've just gone out and collected all the RFCs, the requests for comments that were published by the HDF group over the years, and tried to just put them into one place. So if you go to docs.hdfgroup.org/HDF5 develop, the link is in the notes. Here, each of these RFCs is usually identified by a date. So if you open this, any of these RFCs, there's typically
an identifier here. So in this case, it's 2012, 11, 14. And I have sorted them here by RFC ID. So this goes back to the earliest I could find, not strictly an RFC. This was 2004. The HDF group was actually founded in 2006. So as a company was founded in 2006. So this one actually predates that time. But then, yeah, I've collected them. There might be a few missing. If you know of something that is missing here and you would like to see it, send an email or talk about it on the forum. I will try to shake loose a few more things. I definitely know at least 2 other RFCs that are not here that are more recent, the selection IO RFC and the subfiling RFC. But then, yeah, so I just thought some of it is clear that some of these are outdated, and that's just life. But nevertheless, I personally, and I hope many other users still find a lot of this material very helpful, because some of these documents are very detailed, and sure, maybe a particular API call has changed a little bit, or there's a new argument. But when you really want to know more about the implementation, the concept, sort of in-depth technical documentation, I always find these RFCs very helpful. And we also left a column here for comments. So over time, if there is a comment, an important caveat, an important update or something like that, I hope we can fill that in over time. But at least I personally found it always frustrating on the old website. Yes, everything was organized in a very topical fashion, and when there was an RFC, maybe you could discover the link to that RFC somewhere. But then when I wanted that particular RFC of the existence of which I knew, and then I tried to find it, most of the time I couldn't find it because I couldn't remember of which page it was linked. So I thought, well, let's just have them all in one place, and you can do a search on this website here. So on this website here. So if I do a Control F and I look for metadata or something like that, then it's pretty quickly identifiable here and so forth. So that's one thing, and I hope people find that helpful. Okay, that's as far as announcements go. There was interesting stuff on the forum, but I'm going to pause here and ask any questions so far. Anybody have a problem, an issue, or something you would like to share? No? Okay, then I will just continue. So as always, there are lots of interesting things being discussed on the forum, and I just picked the ones that I like or I have to say something about. This was actually a thread that was going on for some time. This was this user that was using MPI for Pi and H5Pi and so forth. He had sort of an issue with processes hanging when he was trying to do parallel writes and so forth. And he seems like he made some progress there with parallel IO through Python with contiguous layout. It turns out, and these issues are sometimes very subtle, that what he missed was that even in the case of a contiguously laid out data set, there is the default allocation policy, if you want to call it that, is what we call late allocation, meaning when you create a contiguously laid out data set and don't immediately write a value to that data set, nothing actually happens. There's no storage being allocated in the file for that. It really is deferred or delayed until a first value gets written to the data set. And then, of course, the whole data set is allocated sort of as a contiguous region in your file. Now, what that means in the parallel case is rather subtle, because there are these collective calling requirements in parallel HDF5 applications. And I put the link here. It's a nice website that describes which HDF5 API calls have a requirement that you have to call them collectively in all processes. There is a subtle side effect here. So H5D create is one example of these calls that have to be called collectively. And he did that, and that was fine. However, the problem was that in the case of a contiguous data set, the behavior is exactly the same as in the sequential case, that allocation is late, which means that if you don't immediately write a value to that data set, it's not being allocated. And so what that means is, if only one rank later writes to that data set one value, that is one of these situations where you can provoke this behavior of hanging, because then since the address of where the bytes for this data set will be located, that piece of metadata is known or can be known at this point only at that rank that actually does or attempts to write that one element or that one value. It is not, this change is not known to other processes. So the whole thing hangs because all of a sudden you are in a situation where the sort of the logical picture of the file is different between this one process and everybody else. Everybody else just knows that there is this data set, but everybody else thinks data actually hasn't been allocated, so they could not find that out without actually accessing that data set and going to the file. But this one process has sort of this advanced knowledge or this additional knowledge, and that in this case leads to this behavior that on file close, some processes actually hang. And so, yeah, these things like allocation time, fill behavior, and so forth, they happen a little bit under the radar because you typically use default property lists, and you could control these things by changing file access or dataset access property lists. But if you don't, then, yeah, they kind of go under the radar and then have potentially these subtle side effects on what happens actually, especially in a parallel application. And so I think it's always, I have no magic advice to say, here's a checklist, and then if you always do this checklist, then you'll be fine. But I would say you should always ask yourself in parallel, especially when in doubt, and you do a certain operation, what in a way logically happens, and in particular with respect to metadata. If, for example, in the case of a chunk data set, well, if chunks, for example, aren't already allocated, but would be allocated as a result of that operation, well, that definitely means there is a B tree, or depending on how that the chunk index is represented, but in the oldest file format version, that would be a B tree. So if that chunk gets allocated, the B tree needs to be modified necessarily. So metadata needs to be modified necessarily. And if that doesn't happen across all processes, you have a problem right there. So this is, I think, all I can say with respect to sort of thinking about what are potential side effects in operations. And yes, there is sort of this wholesale list of things that says here are the collective calling requirements for these operations, but that doesn't mean that there are not potentially sort of subtle corner cases where that list is unfortunately not complete in a sense. Then there was another interesting post about, it sounded a little bit like Fortran specific, but it's actually not Fortran specific. somebody was having an issue with reading UTF-8 encoded strings, and many people correctly pointed out that yes, if you are reading from a UTF-8 encoded attribute or data set, you have to make sure that this is the encoding that you have set on your in-memory type, assuming you are reading from something that's encoded in UTF-8 on disk, or the other way around. When you're writing to a string data type whose encoding is UTF-8. There is, however, and unfortunately that came not up in the discussion, there is currently a very subtle bug in the HDF5 library in how it handles data type conversion between string data types. So first of all, there is currently no conversion between variable length and fixed length string data types, and that's okay, but it's actually more subtle. It's more subtle in the sense that even if you have two fixed length data types or two variable length data types, the HDF5 library currently does not know that or does not treat what is technically true, the fact that ASCII is a proper subset of UTF-8, which means that if you take a Unicode code point that can be represented in ASCII, the byte for byte representation in the case of ASCII 1 byte, that 1 byte is exactly the same if you treat it as a UTF-8 encoded string. The converse is obviously not true. Since UTF-8 is a variable length encoding up to 4 bytes, so for certain Unicode code points you need 1, 2, 3, or 4 bytes. And then of course the code points that fall outside that range that can be encoded in ASCII, of course there is no conversion, no truncation if you wish, from UTF-8 to ASCII. However, going from ASCII to UTF-8 is just the identity. There is no conversion necessary. Unfortunately, the HDF5 library is what I would call blissfully ignorant about that, which means that if you have an ASCII encoded data set or attribute in the file, for example, and you would like to read that in memory, and in memory you say my data type is, my string encoding is UTF-8, the library will generate an error. Or the other way around, you have an ASCII encoded string, for example, in memory, and you would like to write that to a data set where the string type has UTF-8 encoding. Again, the library wrongfully will generate an error, and that's not good. And if I linked here this, there is a number 544. There is an issue in GitHub where a user actually discovered that, and the details are described in there. We haven't gotten around to fixing it yet, but there will be hopefully a fix for that very soon. Okay, then there was another interesting issue about someone asking when should an MPI barrier be used when using parallel HDF5. Then there is, to my knowledge, only one situation where that might be necessary, which is if you want a certain consistency semantics. Otherwise, if you are just reading or writing, or I think the user's question was related to after file close or after writing something, no, there is no such requirement. However, there is a requirement if you, in a way, have MPI processes that, so to speak, communicate through the file, in the sense that, let's say you're writing an attribute value, or you're writing to a data set, and then you have other processes that are reading from it, and you are making assumptions about when those changes to the attribute or to the data set, when they become visible to writing processes, whether when they become visible to reading processes. Whether there is a delay or in fact, I think out of the box MPI does not guarantee atomicity unless you enable it. So they could be reading old values, new values, or actually invalid values or undefined values is probably the right term here. And so yeah, and in this response, or also here, I linked there is a very interesting RFC on that topic where if you want to achieve a certain semantics, there is a property that you can set to if you want that behavior to, I think the call is, it's called H5P set MPI atomicity or something like that. Then you can use that. However, you would still need some barriers in your application, and that's that. So, but that was an interesting question. And then still there is this topic open that where we collect sort of issues that people might have, nagging issues where they say, I wish the HDF group would fix this or that. That would make my life or my workflow a lot easier. And we want to use that and then sort of present it through a lightning talk or for discussion at the HUG event in October. So if you have something, find this thread on the forum, it's linked from here, and sort of let us know about your issue. And before I continue, question on, are there any questions about HDF5, something that I talked about so far, or no? Okay, then we have 5 minutes, and that's going to be probably too much for 5 minutes, but I'll start anyway. This is something, so tips, tricks, insights, we talk about things, less trodden paths, or things that are maybe not as widely known as they might be, is a thing that's supported in HDF5, but maybe a little bit on the esoteric / advanced, infrequently used side, is user-defined properties. Okay, user-defined properties, everybody is familiar sort of with the property lists, file access, data set creation, and sort of all these different property lists, and you can set properties on there and sort of control the behavior of the library with respect to object access, object creation, transfer of data, and so forth. But it turns out you can actually create your own property list class types. So a property list class type is in a way a property list that has certain predefined properties that are just available that a user can set or get. So like a schema, if you want to wish it, a predefined dictionary, that's what I would call it. And there is a second kind of user-defined properties that works with any property list. So if you have a property list like a dataset creation property list, you can actually insert properties into that property list just on a whim. And I'll show you how to do that in a moment. And so the use, you might say, well, what's the use case for that? Well, the use case, I would say, is really if you would like to pass properties to as part of your APIs in your application, and you would kind of make it all look more or less like HDF5 in the sense that you have handles of type HIDT, and you don't want to reinvent the wheel. And of course, depending on the language that you are using, you might have very nice dictionary structures like in Python or in Julia and so forth. So there's no need. But then if you are working in C, it's the landscape is kind of scarce and sparse. And so if you don't want to reinvent the wheel there, you might as well use general user-defined properties. And I've linked here I've linked here the General Property List Operations Advanced section, where here is a simple example of how you create user-defined property lists and insert user-defined properties, how you read them, how you update them, and how you delete them. And these are sort of, in this section of the reference manual, these are the calls that make all this happen. And of course, I can't go through that here right now. But the idea, just in terms of terminology, is, again, these, when you define a property list class, there are certain predefined properties, and the documentation refers to those as permanent properties. And then the properties that you might just insert into existing property lists, just on a whim, the documentation refers to them as temporary, or temporary in the sense of non-permanent. What I would warn you about is that regardless of if these properties are permanent or temporary, none of this gets actually stored in the HDF5 file for a variety of reasons. However, when you pass these property lists between API calls and so forth, these properties, whether they are permanent or temporary, they are copied and so forth, provided that if you look at some of these calls, you see they are sort of riddled with these callback functions when you register a new property list type, or you insert sort of a temporary property into existing property lists. You have to provide these callback functions. And these callback functions are like in C++, where you have to implement things like copy constructors and destructors and things like that. So that's what these callbacks are. And they just make sure that if your data type, for example, is something that requires dynamic allocation, and if it gets copied, you need to allocate something else and then copy the values over, or you have move semantics or something like that. That's what these callbacks are for. And you have to make sure that if you use this with non-trivial types, that the right things happen. And we are out of time, but if this is of interest to you, again, to me, it's in the category of esoteric, advanced, infrequently used, but in certain circumstances, it might be just what you need instead of writing your own, spending a lot of time testing and so forth. But it then makes the whole thing feel more like HDF5, and you can use sort of an infrastructure that's out there ready to use and might be helpful. Anyway, thanks for coming. I'll see you again next week. And yeah, please send questions, discuss these things on the forum. And yeah, enjoy the rest of your day, and I'll see you next week.